My name is R.Srinivas. I am working as Associate Professor in Vaageswari College of Engineering. Today we are going to discuss about basic block diagram of a communication system. We are going to discuss about block diagram of communication system. So first we have to understand the definition of what is meant by the communication. So if you go through any dictionary, the English meaning of communication is nothing but simply the transfer of information from one point to other. Right? So if you consider, I am saying it as one point to another point. If you have a transfer of information from one point to other point. So what is one point and what is another point? So we can define one point as source and other point as the destination. Right? So if there is any transfer of information from the point called the source to the destination, we call it as a communication. Right? So any transfer of information. Here the transfer of information means the information should be meaningful. Right? So here any transfer of information, any transfer of meaningful information, we call it as a communication. Right? So here in the basic block diagram, the first block is nothing but the source. Right? So source is the place where the information is generated. Right? So here the information where it is generated, we call it as a source. So the informations given by the source, in order to communicate, in order to transfer it to the other point called destination, there are varieties of informations are there. Right? So that varieties of information, the information will be of any form given by the source. The information may be, for example, sound. So sound is one kind of information. Right? Image is also another kind of information. Video is also another kind of information. Text is also one kind of information. So the information may be in any form, will be given by the source. Right? So this information given by the source is given to the channel. Right? So before to the channel, so generally what happens means it is given to the transmitter. Right? It is given to the transmitter. Right? So through the transmitter, it is given to the channel. Right? So it is given to the channel. The channel carries the information. Right? And then at the destination side, it will be received by the receiver, and it is completely supplied to the destination. So this is nothing but the basic block diagram of a communication system. Right? So the information in the form of sound, image, video, text is given to the transmitter. The transmitter is going to radiate your information into the channel. So here the channel is nothing but the free space. So here I am talking about the wireless communication system. I am not talking about the wired communication system. Right? So the total communication systems are two types generally. Right? So first type of communication system we know is a wired communication system. Right? And the second type of communication system we have, it is a wireless communication system. Right? So these are the two types of communication systems we find in the world. Right? So what is meant by a wired communication system? So wired communication system is nothing but if the channel is physically connected to the transmitter and the channel is physically connected to the receiver, we call it as a wired communication system. So what is meant by a physical connection? right? So if the transmitter and channel are connected through a group of wires or a coaxial cable, right? So and if the channel is also physically connected through the coaxial cable or group of wires to the receiver like this, right? So we call that type of communication system as a wide communication system. See here. So I am drawing a line from the transmitter to channel and from the channel to the receiver. So this is nothing but the physical connection. So this type of communication system we call it as a wide communication system. So here this wide communication system is mainly suitable for only short distance communication. It is not suitable for the long distance communication. So why I am saying that it is suited for only short distance communication means, as according to the definition, the transmitter and the receiver and the channel are physically connected through the coaxial cables. So as the coaxial cables or the group of wires cannot be used for cannot be constructed, they cannot be physically connected if we are using it for the long distance communication. So even though if you try to develop a wide communication system for the long distance purposes, the cost of this total communication system will increase. That is the first disadvantage we will get, and the second disadvantage is nothing but, even there is any problem across any length of your wire that is laid from the transmitter through the channel to the receiver, the troubleshooting of the problem which has occurred in this system will become very hard. That is the second disadvantage you will find, right? And moreover, if there is any drop in the electricity across any block of your wide communication system, the information cannot be transferred from the source to destination. So as we have got these many disadvantages, the wide communication system cannot be used for the long distance communication. Especially it can be used for only the short distance communication, that is within the building or within 100 meters of length, right? So for any short distance communication we can use the wired communication system. Right? Now going to the wireless communication system. As the name itself implies, wireless communication system is nothing but, it can be defined as if the source and transmitter and receiver are not connected physically with the channel. Right? So if the transmitter is not connected physically to the channel and if the channel is not physically connected to the receiver, right? So that type of communication system we call it as a wireless communication system, right? So to overcome the disadvantage, to be suitable for the long distance communication and to reduce the amount of construction of a communication system, we are going for the wireless communication system. Right, so wireless communication system is well suited for the long distance communication. Right, so the transmitter, and according to the definition inside the wireless communication system, they are not connected to the channel physically. Right, so they are not connected to the channel physically. So now the question comes is, how the information from the transmitter is transmitted to the destination if they are not connected physically. So the answer is, every transmitter is attached with one type of device called antenna. The transmitter is connected with antenna called transmitting antenna, and receiver is connected with the antenna called receiving antenna. Right? So the transmitter and the transmitting antenna will take the information from the transmitter and it will radiate that information into the free space in the form of electromagnetic waves. Right? So here the channel is nothing but the free space. Right? So as they are not physically connected, right? So the channel will be nothing but, in the wireless communication, it is the free space. The channel will carry this electromagnetic waves, that is the information, and the receiving antenna will receive that electromagnetic waves and it will supply that information to the destination. So this is what happens inside the wireless communication system. But here there are some points to be discussed here, because if we, for example, if we want to transfer a message signal, let us say an information signal of 10 hertz, 10 hertz, let us say. First we have to calculate what should be the height of the antenna, right? So generally the height of the antenna will be measured in lambdas, that is nothing but the wavelengths. But according to the relation, there is a relation between the wavelength, frequency and speed of light. So that is nothing but lambda is equals to c by f, where c is the velocity of light and f is the frequency of the signal, right? So as already I said, if we want to transmit a signal, information signal of 10 hertz, so the length of your antenna should be, right? So as the speed of the light, we know that it is 3 into 10 power 8 meters per second, and my frequency signal is 10 hertz, right? So the length of your antenna comes around 3 into 10 power 7 meters. That is in and around of 30,000, 3,00,000 meters, right? So this 3 into 10 power 7 meters of height of antenna construction is impracticable. So we cannot construct an antenna of this length. So in order to transmit your frequency signal, information signal having the frequency of 10 hertz, we have to construct an antenna of 3 into 10 power 7 meters, which is an impracticable height. So here in order to send your low frequency or low information signals, right? So in order to send that signals across the transmitter, we follow one type of process called modulation, right? So the modulation is nothing but it is going to convert the low frequency information signal into high frequency signal, right? So modulation is a process that convert that low frequency signal to high frequency signal. For suppose if you are using, if I want to send an information signal of 10 hertz, right? So if I apply the modulation over 10 hertz signal, the same signal will be converted into around 1000 megahertz. Sorry, it may be converted into 100 megahertz signal by using the modulation process. We have already calculated the length of antenna for transmitting the 10 hertz signal, that is 3 power 10 meters, right? So after applying the modulation on the same frequency signal, we are converting it into 100 megahertz signal. So now we will try to calculate what is the height of the antenna, right? So this is 3 into 10 power 8. So 100 megahertz is nothing but 100 into 10 power 6. So 8 will cancel. So automatically after doing modulation, if we apply the modulation, the same lambda, that is the wavelength or that is the length of the antenna, is reduced to 3 meters. So the 3 meters construction of antenna is a practicable one, right? So in order to transmit your low frequency information signals, we allow the modulation inside the transmitter. So already I have indicated with a small process, that is nothing but converting the low frequency signal into high frequency signal. We call it as a modulation IC. But according to the communication system, the modulation is nothing but simply, in order to do the modulation here, so we require a information signal, that is the message signal, right? And we require a carrier signal, right? So this information signal is nothing but a low frequency signal here. Information signal is nothing but a low frequency signal, and carrier signal is a high frequency signal, right? So this is nothing but requirements of your modulation, right? So even though the modulation is converting a low frequency signal into high frequency signal, from that definition we require these two signals: information signal, which is a low frequency signal, and carrier signal, which is a high frequency signal. So now if you try to define in a proper way, so modulation is nothing but it is modulation is a process of superimposing the low frequency signal onto the high frequency signal, right? So here for a signal generally, if you discuss the characteristics of a signal, you have the amplitude, you have the phase, and you have the time period whose inverse operation is nothing but the frequency. So here there are three types of modulations are there. One is the amplitude modulation, right? So you have the first type of modulation is nothing but amplitude modulation. Second type of modulation is nothing but frequency modulation. And third type of modulation is nothing but phase modulation, right? So these three types of modulations can be carried out in order to transmit your information from source to destination. So in the second